I'm talking with Lauren Wieserbron. Did I say that right?
Yes.
Okay. And she's a summer intern with the REU program. Could you tell us what that is and what you're doing?
So the REU program is an NSF-funded program. Stands for Research Experience for Undergraduates. And so I'm here at the University of Delaware for the summer. And I have a summer-long project, and at the end I write a paper and present my results.
Okay. Would you mind taking us out to your van and showing us what you're doing out there? All right. What's this thing here?
So this is the pump for our instruments. We have water going into the van, and
I see a lot of batteries in here.
yes,
I see some hoses.
pretty powerful pump. So this is the water going out. This is the water going in. It's not on right now.
Okay. And what do we have over here? It looks like some kind of rope running into the water.
Yes. So down here at the end of the rope, there is a carousel which has a CTD.
What's a CTD?
It's an instrument that measures conductivity, salinity, temperature, and pressure, which is depth. And it has a PAR sensor on it, which measures light irradiance. And it has a turbidity sensor, which measures the particles in the water, and a chlorophyll A sensor, which measures the gross chlorophyll A.
Okay. Turbidity and chlorophyll A.
Yes.
Okay. And so all these things, looks like they all run into the van here.
Yes.
Right.
They have a computer on the other end that takes in all the values.
All right. Let's go take a look. Doesn't look like a bad spot to do an internship. Ooh, and luxurious accommodations too.
Very, very large accommodations. So this is our half.
Hold on, let me take a look here. All right.
This is their half.
This is, so it's split into half. So this is
Yeah.
Dr. Luther's stuff over here.
Mm-hmm.
And then all this stuff over here is yours.
Yes.
Okay. Can you explain to me what this is and what it does?
So the pump pumps in water this hole.
Okay.
Runs through the tube.
All right.
Then it's split into two. Half of it goes into the SUNA, which measures nitrates.
And why do you measure nitrates?
We measure nitrates because it's an important nutrient for phytoplankton.
Okay.
And we want to see how healthy the phytoplankton are. So this is a good indicator.
Okay.
And then the other half goes into the FIRE.
Fire.
FIRE stands for fluorescence, induction, and relaxation.
Okay. So what does that do?
It's a pump and probe fluorescence measure. So what it does is it flashes light and then reads the fluorescence coming back.
Okay.
The phytoplankton.
Where does it do that? Where does it do that?
So it does that in here. This is a continuous.
Water comes out through this little tube here?
Yeah, water comes out through this little tube and then goes out through this one, and then we just let it run.
Okay, and then it gets pumped right back out into the water.
Yeah, and then this is the exit hose, so it just, there's a hole in the back and it just runs out back into the bag.
So what's the purpose of the FIRE? What does that do?
So we're most interested in measuring FeO/FM, which is a measure of phytoplankton's photosynthetic efficiency, and that allows us to know how healthy the phytoplankton are and how well they're photosynthesizing, which is crucial for this project.
And how do you do that? What does the FIRE sensor do to try to measure the efficiency?
So it flashes a strong light pulse and measures the fluorescence coming back, and then flashes a weaker light pulse and measures the fluorescence coming back. And it takes the difference of the two, and that indicates how well it's photosynthesizing.
Okay, and are you doing this all day long?
I'm doing this only in the mornings because that is when there is the greatest light fluctuation, when the sun is coming up. So it's really easy to see the difference in FeO/FM.
So you see a change as opposed to if you did it during the daytime, it'd just be pretty much a static reading?
Exactly.
Okay, excellent. So I see another piece of equipment here. What's this do?
So this is the Coulter Counter.
The Coulter Counter.
Yes. With this we measure the particle concentration in the water.
Particle concentration.
You put a little bit of water in here. You put it in here and put it up like this. And this tube sucks water up and measures how many particles come up and their size.
Okay.
And so that's just helpful for knowing how many cells there are, and also just what the particle content is of the water.
Okay. So then I guess you got a big day coming up here on Friday. What happens on Friday?
Yes, well, on Friday I'm giving a presentation, which I guess is supposed to be the culmination of this whole internship.
Okay.
I'll be presenting my results.
Excellent. Well, thanks for taking me through this.
No problem.
All right.